Hello everyone, let's meet our team. Firstly, my name is Ainnur binti Muhammad Sulung. Secondly, we have Mia Ainsyara binti Tata Meme, and we also have Fatin Nur Nadirah Rizal. Then, we have Harmi Harina binti Muhammad Har, and we also have Nur Alia Husna binti Syahrir Zaidi. Lastly, we have Muhammad Shameem bin Muhammad Sharif. The objective of this experiment is to determine the coefficient of static friction of different surfaces.
The theory of this experiment is vector values such as force and velocity possess both magnitude and direction. The speed that an item is traveling in a particular direction is its velocity. When an item accelerates or experiences a change in velocity, force is created. A body at equilibrium at a rest exhibits resultant force, which is the zero sum of all force acting on the body. An attracting force called gravity occurs between two masses. The mass of the masses determines the force magnitude. An approximation of gravitational force acting on an item on Earth is F equal to mg, where g is gravitational acceleration and m is object mass. An object weight is the amount of the gravitational force acting upon it. When two objects come into contact, a normal force is a contact force that operates perpendicular to or in the normal direction of the contact surface. The free body diagram of a mass sitting on a horizontal surface with a normal force equal to the gravitational force is seen in figure 5.1. The force that prevents two surfaces in contact from moving relative to one another is called friction. Friction comes in two types, kinetic and static. The friction that operates on an item at rest is known as static friction. The force that has to be overcome in order to move a stationary item called static friction. The static frictional force maximum value is provided by Fs maximum equal to mu Sn, where n is the normal force and mu s is the coefficient of static friction, a dimensionless constant that varies depending on the item and the surface it is resting on is the coefficient of static friction. The friction that applies to a moving item is known as kinetic friction, and the kinetic frictional force is determined by Fk equal to mu Kn, where n is the normal force and mu k is the coefficient of kinetic friction. In this experiment, the frictional force on a horizontal and inclined plane between a wooden block and a rubber surface will be measured, and coefficient of static friction will be determined from a plotted data.
Now let's look at the method of the experiment. The method of the experiment was used as a reference to do the experiment to make sure the experiment is done smoothly. I will talk more about it on the next slide.
Next, we move on to the method of the experiment. First, the mass of wooden block that was measured was recorded as m. After that, the apparatus as shown in figure 5.2 was set up. Then, the tabletop was made sure to be stable and horizontal to the ground. Furthermore, the spring scale and the wooden block was attached with a string. It was placed horizontally on the tabletop. The rubber side of the block was made sure to be faced downward. After that, a M equal to 50 gram mass was placed on the wooden block. Then, the spring was pulled away. Once the block started to move, the spring scale reading was recorded. The value as Fs and table date was recorded in table 5.2. Then, step 4 until 5 was repeated for 3 trials. Furthermore, another 50 gram mass was added from the wooden block, and step 5 to 6 was repeated. The steps was repeated until total of m equal to 500 gram mass is on the wooden block. Lastly, step 1 until 8 was repeated. This time, the rubber side of the block was made sure to be facing upward. The data was tabulated in table 5.2.
For result, this is result for rubber surface towards the floor. while this is result for non-rubber surface towards the floor.
So for the first analysis for this experiment is draw and label the free body diagram of the wooden block.
From the data we already got, we have to plot graph of static friction force against normal force. As you can see, this graph are for the rubber surface. After plot the graph, firstly, we can determine the gradient by using formula m equal to y2 minus y1 over x2 minus x1, and we get the gradient is m equal to 0.x7. Then we have to find the central coordinate. To get m maximum and m minimum, we use formula total y over n and total x over n, and we get the central coordinate at y-axis is 2.76 and at x-axis is 2.73. Then we have to determine the m maximum by using formula m equal to y2 minus y1 over x2 minus x1, and we get the m maximum is 1.0125. By using same formula with m maximum, we can get the m minimum, which is the m minimum is 0.7115. After that, we have to determine the delta m by using formula 1 over 2 multiply with m maximum minus m minimum, and we get the delta m is 0.15. Lastly, for this graph we have to find the percentage error by using formula modulus x minus y over y multiply with 100%, and the percentage error we got is 13%. Next, we move on graph of static friction force against normal force for non-rubber surface. Same with rubber surface, firstly, we can determine the gradient by using formula m equal to y2 minus y1 over x2 minus x1, and we get the gradient is m equal to 0.83. Then we have to find central coordinate to get m maximum and m minimum. We use formula total y over n and total x over n, and we can get the central coordinate at y-axis is 1.28 and at x-axis is 2.75. After that, we can determine the m maximum by using formula y2 minus y1 over x2 minus x1, and we get the m maximum for non-rubber surface is 0.52, and for the m minimum is 0.28. After that, we have to find the delta m by using formula 1 over 2 multiply with m maximum minus m minimum, and delta m that we got for non-rubber surface is 0.12. Lastly, for the calculation on this graph we have to find the percentage error by using formula s modulus x minus y over y theory by multiply with 100%, and we get the percentage error for non-rubber surface is 24%.
Analysis number 3. Use gradient obtained from the graph to calculate the coefficient of static friction for each surfaces. So this is the difference of coefficient that we get from the graph. Rubber surface toward the floor and non-rubber surface toward the floor. We get from the equation y equal to mx plus c. We compare with fs equal to mu fn. For the next question is compare and discuss the coefficient of static friction obtained. The magnitude of coefficient of static friction obtained in table 5.1 is greater than the magnitude of coefficient of static friction in table 5.2. When the rubber surface contact with surface, the friction will be higher compared to non-rubber surface made a contact with the floor. A higher coefficient of friction means that more friction force is present relative to the normal force.
How can anti-lock brakes stop a car in a shorter distance than regular brakes? An anti-lock braking system, ABS, is a safety feature that prevents wheels from locking and out of control while skids. As the ABS apply, the wheels will not lose traction with the road and will not simply slide due to continuing motion. So, the car will stop in shorter distance rather than the regular brake that will lock the wheels of the car. Question 2. From your experiment, which material has the highest coefficient of static friction? From our experiment, the wooden block with rubber has the highest coefficient of static friction. Then, does this agree with your hypothesis? Yes, it does agree with the hypothesis, which is the rougher the surface, the higher the frictional force. Lastly, what do you think determines the coefficient of static friction? The coefficient of static friction determined by the ratio of maximum static friction force between the surface in contact before movement common to the normal force and depends on the material used. Question 3. Once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. For the wooden block with rubber, the mass undergoes stop and go motion. This is because it has high coefficient of static friction that influence the friction on the object. So, higher friction exists that prevent the block move freely and cause the stop and go motion. While for the wooden block without rubber, the mass moves smoothly. This is because it has low coefficient of static friction that causes low friction exist when the mass slide against surface.
A retarding force that resists motion of object that is contact with another of surface is called friction. Friction is affected by the weight and the surface material of the object. The friction increases with the block weight. However, friction is independent of the size, the surfaces that are in contact. Force exists when object accelerate with gravity acceleration F equal to mg. The magnitude of the force depends on the magnitude of the masses. Normal force is a contact force that is perpendicular to contact surface between two objects. Friction is the force that resists the relative motion of one surface in contact with another. There are two types of friction, which is static and kinetic. The friction that acts upon an object at rest is static friction. Static friction is the force must be overcome to move static object. The maximum value of static frictional force can be calculated by maximum static frictional force equal to coefficient of static friction multiplied with normal force. The equation is Fs max equal to mu normal force. From the experiment, it shown that different materials have different coefficient of static friction. The rubber surface has a higher coefficient of static friction, while the non-rubber surface has lower compared to the rubber surface. The coefficient of static friction value is 0.87 for graph of static friction versus normal force for the rubber surface, and non-rubber surface is 0.38, the result in the expected straight line. Human error may be identified as the source of error in this experiment. Mathematical error may occur while rounding numbers or when collecting and visualizing data. Another possibility for the inaccuracy in this experiment is parallax error. Another thing to keep in mind that parallax error occurs when a device's pointer seems to be at incorrect position and view sideways as opposed to frontward. The reading may not display precisely when seen at angle due to the distance between the scale and the pointer even if they are on the same plane. Avoiding parallax error and read the device straight from the front scale is the simplest way to solve the problem.
The conclusion is the experiment used a wooden block with a rubber coating on one side to calculate the coefficient of static friction for various surfaces by exerting several pressure on the block and determining the greatest force necessary to start it moving. The coefficient of static friction was computed. The finding demonstrated that the surface in touch with the wooden block rubber covered side affected the coefficient of static friction. Higher coefficient of rougher surface suggested more resistance to motion, while lower coefficient on smoother surface suggested less resistance. In real-world scenarios such as braking system design, force calculation, or moving objects on various surfaces, and mechanical system stability, Knowing the coefficient of static friction is essential. The experiment yields insightful information on the behavior of various surfaces and may help advance research and the creation of more dependable and efficient system for a range of business.